We will be looking at for the past 1 hour, for the next 1 hour, we will be looking at some things that are technologically advanced and what are they and how we can use them in research perspective as well as advancing our careers. So all those things. Okay. So the title of my talk today is Wearable Intelligent Devices. And what is this wearable? So we have three terminologies here: wearable, intelligent devices, right? So I'm going to explain each and every terminology in detail. So this talk will be basically, I will try to focus on from the basics to the advanced version. Let us see how well we can manage within the time gap we have. So, starting with wearable technology, most of us are accustomed with this terminology, but we don't know what exactly this terminology means. Correct. So, what is a wearable? A wearable is something, anything that can be worn as an accessory. Like we are wearing different things, right, in our day-to-day life. Like for example, we are wearing watch, we are wearing glasses, shoes, rings. That is our what is the chain, rings, jewelry. So all those things are called as wearables. Now, when we try to integrate technology with this wearable, okay, so that is, it means that if I am integrating the term technology, then it by itself it understands that I have some electronics associated with that wearable technology. Like for example, I have a normal watch. I want to increase the functionality of that watch. What do we mean by functionality? I want the watch to do something else other than it is designed for. That is, whenever I have, like for example, watches are actually designed to note down time or give time to the user, right? But if I want it to perform more than that, for example, I wanted to count my the steps that I'm walking. I wanted to identify the heart rate, then I'm integrating technology with it and I'm wearing it as an accessory again. So that is why this technology is called as wearable technology. Okay. Now, why do we need that? Basically, all improvements in technology are done to facilitate mankind, correct? So it will enhance the mankind. It will actually try to enhance the daily activities of mankind. So that is what we try to achieve by evolution of technology. So it tries to bring the technology closer to our lives. Like for example, it is with us now. Like for instance, you can also think of mobile phones. How mobile phones have dominated the market right now, right? Because it is with us. The technology is near to us. It is helping the humankind. So that is how wearable technology is going to help. So what are the different kinds of so if we talk about wearable technology as such, we have different layers present in this wearable technology. Okay, so the initially whenever we talk about wearable technology, technology means, so I have something that is integrating some sensor that will be there to pick up the data from. So I have a sensing layer, I have a network layer that communicates with the sensor and the next layer. Okay, and also I have a data processing and storage layer, and it also contains the service layer. So what is this sensing layer? Sensing layer primarily consists of sensors that are embedded within the wearable device, and they can include different kinds of sensors. So you can see different parts of the from different parts of the body. I can wear anything that can actually that are capable of sensing the information from the user and transmitting it to the next layer. So this layer, so we can see headbands, we have badges, camera clips, we can take images, we can have smartwatches like that. So we will go into detail about all these things. But the next layer is about network layer, wherein the connection from the sensing layer to the data processing layer should be established, which contains there are many network devices that can be used as of now. Simple thing is Bluetooth. We can use Wi-Fi. We can use other sort of communications as well. But generally, more commonly used devices for transmission of information is Bluetooth and Wi-Fi, right? And we also have data processing and storage layer. Why do we need this data processing layer? Because whenever we have information that is from the sensing layer, I get some information, right? I need to process that data and I need to store it in some I need to store it in some device so that it can be used for further analysis. So for that purpose, I have something called as a data processing and storage layer. The next layer to this is service layer. So you have some information that is gathered, that is processed, and you would have some inference from this layer actually. Like for example, heart rate is measured for a person continuously. If the person is having a higher heart rate, like arrhythmia conditions, if it is there, then what will happen is this data processing layer will give us a indication that something is wrong with the person. So it can be transmitted directly to the service layer where it can be notified to the emergency support or to the family members or whatever it is. So that can be taken care of with this service layer. Okay, good enough. So there are many people, if you can see, who are doing research in wearables. So be it in different layers, you can see sensing layer. Some people have been involved in sensing layer. Some have been involved in network data processing, data analysis, and some are involved in the service layer as well. So whenever we want to go into a particular research or we are spending some time, right? We are actually using our time to develop something, understand some concepts, and identify what is the problem with that particular device, enhancing the device, all those things we are doing, correct? So before doing all those things, the primary objective, what we are supposed to do is you need to take a market survey. So you need to understand you are spending some time, whether that time that you are putting in is worth it or not. It's not just for paper, or it's not just for writing a research article or something, but rather if we can think about commercializing it, like we are putting some time, investing some energy. So how about commercializing it and how about making it useful for the society? So if we think in that aspect, then we need to identify what is a market survey. Okay, so let us talk about wearables market survey as such. And when we look at the market survey, it includes both global market survey as well as Indian market share, because some things that are acceptable globally, like in the Western world, some things that are accepted there will not be suitable for the Indian market. So that is why we directly look at both the shares. So if you see the wearable market as such, the wearable market is actually having a improvement or increase in a market share if from 2016 to 2026. This is the projected increase that 2026 is being shown. So you can see that there is a nice improvement that is happening from 2016 to 2026. So market is actually growing, right? So even if we are investing our time, surely we can have some commercialization aspect to it. Similarly, if we see the global sales, the number of wearables that are sold globally. They include, like you can see, smartwatches, wristband, clothing-based wearables, earwear modelers. So all the wearables that are being sold are actually having an improvement. You can see the from 2018 to 2022, the number of units, the number of units that are sold are increased, right? Even if we can see in our own lifestyle, right? So how many are having digital watches? Like before 5 years, not many were using digital watches, right? So we are predominantly using analog watches. But now, currently, the situation has turned around. Why? Because as more and more wearable or digital watches came into market now, the amount of users that are using the digital watches are also improving. Based on this, the cost is also reducing, and so more market share is being occupied by these digital watches. Not many are preferring analog watches now because of the a technological advancement, right? I can use, watches. I'm already wearing a watch, but if that watch is going to give me more functionalities, then I'll be interested in that, right? So Like this, global sales are also increasing. And if you can see, Indian sales are also increasing, and the Indian market share is actually occupied mainly by different kinds of wearable units. Like boat is one of the very familiar market. I mean, a very familiar brand in India. We have OnePlus, Realme. We have Noise that now that is actually very familiar, very famous now, and Firebolt is there. There are other other distributor or brands also that are coming inside the Indian market. Okay, so good enough. Wearables are very nice. They are actually increasing in market share actually. So investing our time in this particular area will surely yield some kind of response or some kind of commercialization technology aspect out of it. Correct. So let us go ahead further and understand or identify how wearable got evolved. So we saw what is a wearable technology. We saw what is market share that is getting occupied. Let us go in depth in wearables and identify what are the how evolution happened and what kind of wearables are there in the market. Okay, so if anybody can guess, what is the first wearable that got invented? Anybody can answer. Maybe take a guess. You can either answer you can just unmute yourself and answer, or you can just type it out. Just take a wild guess. Can I expect some answer? Okay. Okay, so I will give you the answer. The first wearable that got invented are eyeglasses. So I have some answers. Somebody answering here. Okay. So anyway, so the first initial wearable that got invented is in 1200, like 1200 in the sense you can think of how many centuries back. So this was the first wearable that got invented. It's an eyeglass basically. And this is actually made of bones. If you can see, these are animal bones that are being made of, and this was mainly used for people to look at things in a closer look. So that is what. So people didn't have any eye disorders as such, but they wanted to look within to an object in a nearer way. So that is why these eyeglasses were invented. So there are many wearables that got came into the picture after this eyeglasses. So there are different types of wearable devices basically. So if you can think of the like when we are looking at a conventional accessory type, like when we are wearing something, okay, so they are all called as portable wearable devices. Okay, we are able to wear it, we are able to take it from one place to other, so we are able to utilize it in different places. So they are called as portable devices. We have patchable devices and also we have implantable devices. Okay, so these are the main categories of wearable devices. So if you can see portable devices, we have different examples of portable devices: smart glasses, trackers, we have smart watches, we have shoes, we have GPS trackers, we have smart clothing as well. So you can imagine you are wearing some clothing, and that clothing is actually able to sense what are the various signals from your body. Like for example, ECG, it is able to sense. It is able to sense the temperature, the variations in temperature throughout the day. If it is able to sense, so all those things are very interesting, right? So these are called as portable devices. In the other category, we also have something called as patchable devices, meaning they are patchable sensors that are stuck onto our skin. Like maybe mainly it will be skin only. So we have band-aid type sensors and we have tattoo type sensors. Okay, so these are called as patchable devices. And also the other category, which is called as eatable or implantable sensors, are something like bionic eyes. We have smart lenses, we have smart pills, smart pills can be ingested. You can just swallow the smart pills and it can be able to sense the information. We have something called as the endoscopy that is actually miniaturized into a smart pill. You can just swallow the pill. The pill has a camera embedded within it, and as it travels down your esophagus, it can actually capture the images of your esophagus. So it is an alternative to the very difficult endoscopy technique, which is actually still followed, but still these kind of smart pills are coming into the market slowly, and probably in another 10 to 15 years they will take up the market. So, okay, good enough. We are having we are having different kinds of wearable devices. Let us focus on only one type, one particular category, and let us go into in detail. So, I'm going to talk about a detailed analysis of a particular wearable device, and I will understand. I will explain it to you in the technique which is actually interesting till the stage of intelligence that is being incorporated into the wearable device. Okay, so let us be together here. Now, we will talk about eye devices, okay, because it is more familiar, more in the market as well. It is actually a evolving arena where many people are actually identifying these devices to be included in the lifestyle of the person. Okay, so wearable eye devices, you can see how the evolution has happened. So we have different eyeglasses. So you and I, we are wearing eyeglasses, right? Many people are wearing eyeglasses now. So what if I enhance? So if you can remember, we spoke about wearable technology as additional technology or additional functionality embedded within the wearable device. So this is a wearable device. If I have some electrodes or sensors embedded within here, okay, then they become a smart device or a smart wearable device. So this is a smart eyewear by Google Glass. So you can see there is the camera here. So this camera is actually used to project something, and many people are actually having Google Glass, but it is not as familiar as your smartwatch nowadays, right? So but still it is actually getting evolved, and people are trying to utilize it. The next thing is about the VR, okay, or AR MR headsets. So you can see we have a normal PC which actually get extended has the HoloLens. HoloLens are something which is actually, you can think of it as a personal computer on your eyewear, but it doesn't have that fast functionality, but still it is actually an extension of your computer as a wearable. Okay, and we have gaming technology. So in the gaming technology, you can see people are having consoles, and we can use those consoles to have a gaming experience, right? But they got evolved as a virtual reality gaming modality. So you can see a VR glasses which are being worn, and there are joysticks which can be controlled for this gaming purpose. So this is one way on how the wearable eye devices got evolved, and based on this, we can see that there are different kinds of eyewear. So you can see we spoke about this smart glasses. So I had told you, I had indicated that there are sensors that can be embedded within the eyewear. So what kind of sensors can be integrated? So if we are thinking about eyewear, we think about two biological signals. That is, one is EEG and the other one is EOG. What is EEG? Electroencephalograph. That is actually identifying or capturing your brain waves. Okay, so we have we have technology to capture the brain signals, and as well as these are EOG sensors. EOG sensors are something that capture the eye movements. Okay, so why are these eye movements important? Because where I am looking at, or we call it to be as gaze, we will understand more about it in the coming slides. Okay, so these EOG sensors can be integrated to understand where a person is looking at, what kind of eye movements are there. So all those things can be identified using these smart eyeglasses. So there are, if you can see, there are different kinds of eyeglasses that are being in the market now. So these are all prototype versions. They are not commercially available as of now. Whatever I've shown you is actually a prototype version. There are different glasses. You can see a goggle type glasses are there. You can see there are 3D printed glasses that are there, and some glasses actually have different other purpose as well. Some glasses can be integrated with cameras, some can be coated with UV protection. So all those things can be done within a single accessory. So you can see one accessory can do multiple functionalities, correct? And so this is a category of wearable eye device, the smart glass. The other category is something called as VR headsets. So we had seen that VR headsets are mainly used for gaming, right? I had told you just in the previous slide, they are mainly used for gaming. But research is there in the researchers are going towards something called as virtual senses. Okay, what do you mean by sense? So we have different sense organs, right? Nose, ears, and we have tactile. That is skin as a sensor, right? So these are actually the only thing that is not available right now in our commercial setup is I cannot sense smell virtually, correct? You cannot taste virtually. You cannot have a virtual tactile sensing. Like people from far away, I'm not able to touch them. Correct. So people are working on these kind of scenarios for some time now, and this is called as this is one example which I had come across, which is very interesting actually, where this is actually odor generator, and a virtual odor can be used to understand, or can be used for as a sense for the other person. So you can see a person who's wearing a what is that, a VR thing, VR headset is actually giving an input that what kind of sense smell he wants to actually perceive, right? So there is something called as odor generator, and this odor generator will try to identify what kind of smell should be generated, and it is able to simulate a particular area in the brain, which is called as an olfactory area, which is actually which also which is mainly used for vision, but it also uses. So when you can see, whenever I am seeing something, I relate it with the smell also, right? If you're seeing a rose, you know that rose, how rose smells. So you are actually simulating that particular area, and thereby you can actually virtually create that smell. So create an odor. Okay, so that is how this odor is being created. And also one more thing is where they can be used for different purposes, like clinical therapy, odor therapy. We can use it for emotion control. Like I can calm a particular person with using this kind of smell, and we have rehabilitation. So some people cannot actually sense smell. So we have something called as rehabilitation, like olfactory lobe rehabilitation. So all those things can be done. So this particular setup is very interesting, or this particular research is very interesting. So this also can be done using virtual reality. Right. So similar to this, we can also think about something in terms of tactile sensing, like how a person will touch, how will it feel. So tactile sensings can also be done using VR, and there are several other research that have been happening using taste as well. Okay, so whether a person can virtually taste something that is being cooked for far away. So all these things are nice advancements that are being happening in the VR domain. Okay, and the other category is something. Am I audible? Sorry.
Now it's audible, ma'am.
Okay, okay, thank you. Um, okay, so what kind of the next type of wearable device is a smart contact lens. So what are these smart contact lenses? They are basically, you can think about it as a lens that is being used for different purposes. Okay, so we know that there are lenses, right? So we use them for in day to day life. We use them in day to day life, like how we are actually using the how we are using using it for correction, right? Like what is that, eyesight correction. So in addition to those contact lens, the activity that are being done by contact lenses, we can also have other activities like eye tracking. We can use it for diagnostic applications. How it can be used for diagnostic? Using the tear. Okay, so tear is actually one of the nice metric, like blood and sweat. So there is actually more research upon right now on how to use that for different diagnostics. So smart lenses come directly in contact with these tear, and they can be used for these diagnostic applications, like identifying glucose levels, identifying other parameters as well, like how whether any infections are there in the system, and so right. And also we also have the other kind of devices which are actually for other kind of devices for intraocular pressure measurement, and can also be used for therapeutic applications like phototherapy. We can use for thermotherapy. So there are different applications that can be um, used for using these contact lenses. So they are coming slowly into the device. Yes, is there any problem? So the next category of it is eye tracking. So what is eye tracking? Eye tracking is nothing but you can think about it as wherever your eyes are looking at. So you are trying to understand how your eyes are looking at a particular object and how that object is actually influencing your thinking process. Okay, I don't have a particular example, but still, if you can imagine it, you have seen many. Instances where you look at an object and you identify it in two ways, like there will be an image, they will say what you look at it at first and what do you imagine it, that is how your character is, something like that, and all you would have come across, right? So they are basically based on this eye tracking. Like for example, there is a dolphin and a horse, okay, embedded within each other into a single image. So which one you look at first, it depends on where your eyes look at. Okay, so that is an important thing. So this eye tracking has several applications right now. If you see nowadays, eye tracking are very much in the market. You can see eye tracking devices in the Amazon. You can get those things in the Amazon, like you can just spend some 20,000, 30,000 rupees, you can get eye tracking devices. So it is commercially available, but still research is going on in this area of eye tracking. So there are different kinds of eye tracking devices. We'll go into detail about eye tracking because I'll talk about it and I will try to explain you how it can be used to sense something intelligently. Okay. Now, there are mainly four types of eye tracking devices, wherein one is called as head stabilized eye tracking. You can see the head of a person is actually resting on a platform, and sorry, the chin of the person is resting on the platform, and the head is stabilized, wherein the head will be stabilized and the person is actually looking at something that is there in the monitor, and this will give the information on where it is. So because the person is wearing so you can see here the eye tracker device is there, this will capture the where the person is looking at, that is it will capture it will record the eye video basically, and it will try to understand map where the person is where and all in the monitor the person is actually looking at. The other category is remote category, wherein you can see this is actually an eye tracker. So something like this, it will be there, or you can actually mount it on the PC as well. Here, you can keep it here as well. Okay, so this is mainly used for people who are like children and other people where you don't want the head to be stabilized. You want the person to be freely moving, freely shaking their head and other things, but still you want to track the eyes. Okay, That is where this comes into picture. The other one is called as mobile monitor. Mobile monitor is something like eye tracker is somewhere in the you have IR sensors or IR camera and RGB cameras embedded within the car, and the person is actually looking at it, and the person will be driving. He will not. It will be a completely irrelevant place, but still it will be tracking your eyes, tracking your head movements and other things. This is another one wherein within the VR itself you have embedded eye tracker. So eye tracker will be present within the VR inside. So I did not it is not visible in the image, but you can think about it as within the VR it is present, and within the VR you can see that it will be capturing the eye images continuously, and it will be identifying how the performance of the person is for this particular gaming or this particular rehabilitation control or something like that. So whenever they want to understand that, they will try to go into these kind of devices. Okay, good enough. So what are the different applications of eye tracking? We saw different things, right? So we will talk about applications in detail. So there are different applications. One main thing is HCI. HCI we will talk in detail. So I will try to identify and give a brief intro right now. So HCI is something called as human computer interaction, or we can also look at it as brain computer interaction. Both are common terminologies that are used. Now, this HCI, what I want to do with this is based on where my eye is looking. So you can think of it as a virtual keyboard. You can see this virtual keyboard functions just by your eye control. So wherever you are looking at, that will be actually that letter will be clicked on. So you can see a this person is currently looking at the at where eye is, right? So and that eye is actually in focus now, and that will be typed. So like this, these kind of controlling the computer or controlling the machine using a human signal is called to be as a HCI. So this is where eye trackers can be used. One important application. The other nice application is something called in gaming. So even in gaming, you can see this is actually an eye tracker. So here you can see this is an eye tracker which actually captures the movement, head movements and eye movements, and it will try to understand. It is actually a medium where it is trying to understand how the person is actually looking at the game, how he is actually interested in the gaming. So gaming world is actually very huge. We Those who are interested in that, those who are actually working on it, they will know more. But still, if you can see, there are so much of research that are going in gaming because it can offer different kinds of controls. Like we can even use gaming as a therapeutic medium. There are many different things that can be integrated into gaming. So that is why gaming market is actually growing even now. And you can see eye tracking that can be integrated within gaming can provide more information about the person who is playing and how he is looking at the things that are being displayed onto the monitor. So all those things can be understood easily. The other nice thing is driver monitoring. We spoke about this in the last slide. You can see there are different cameras. I had mentioned that there are IR cameras, thermal camera, RGB cameras that can be placed onto the inside of the car, and it will be mounted inside the car, and you can actually it can identify how the person is driving, whether he's in a panicking mode, anxiety state. All those things can be identified very easily using this eye tracking, where he's looking at, whether he's sleeping or not, what kind of situation he's in. So all those things can be identified very easily using this driver monitoring system. Other nice thing about this eye tracking which is very important actually in today's technology, is medical diagnostics. Can I use eye tracking with medical diagnostics? So this was actually an article that was published last year in 2024. This was actually a health technology magazine which published this particular article, and you can see that the title of the article itself says that improving eye tracking to assess brain disorders with wearable sensors. Right. So nowadays, even in people from different universities, they are understanding, they are trying to understand how can we track brain disorders, or how can we diagnose brain disorders using this eye tracking. Because if you can imagine a world where eye trackers are very common, like how we are using watches, and if we can identify where people are looking at, what kind of how your eye movements are, all those things we can track very easily. And if I can use this information to understand brain disorders, then it will be a huge breakthrough, where because this all this can be continuously monitored, all this have can be taken data continuously, right? So there will be a huge breakthrough in identifying different brain disorders with these sensors. So this is one article where it says that eyes are extension of brain, because it is very because eyes control your brain most of the time, on how what kind of visual input is being given. Many functionalities are controlled by your brain. So eyes are the extension of the brain, and it can be used to provide signs for these disorders, and it can also identify what causes them, right? So because I'm tracking it continuously, I'll be able to understand the pattern that is being there, and what is the major cause, underlying cause of these disorders can also be identified very easily, very nicely with the help of these eye trackers. Correct. So now, so what kind of eye tracking devices have been used to identify brain disorders? So you can see there are research that identifies different neurodegenerative disorders like Parkinson's, Alzheimer's using eye blinking patterns. So they say that the blinking pattern differs whenever the person is actually affected by these disease conditions. So early diagnosis is possible. When early diagnosis of some any neurodegenerative disorder is possible, then it is very good, because people suffer the most in neurodegenerative disorders. If you have an experience with somebody, or if you know what are neurodegenerative disorders, it is very painful. Like people tend to forget their names, they don't even know who they are. So all those things are very common in these neurodegenerative disorders. So if I can do an early diagnosis in these, it will be very helpful. So those things are possible with these eye tracking devices very nicely. And we also have some kind of ocular movements that are linked to brain disorders. Blink rate and modulations are different in children with ADHD, that is attention deficit hyperactivity disorder. ADHD is very common nowadays, where many children are actually acquiring this particular disorder. And you can see that if it is actually identified early enough in the very younger age, then we will be able to control the progression of it, right? So we can delay the progression, and we can control how the disease condition manifests. So all those things are possible with the help of these kind of techniques. Also other there are something called as motor neurons in the brain. So these are linked with eyes as well, and their muscle, and also they are known to be associated with autism as well. So like this, you can see medical diagnostics also can be enhanced using these eye trackers, right? So so now we have seen we have got an overall idea about what kind of wearable eye devices are there, particularly what are the eye tracking applications that are actually useful. Now, if you are to design this eye tracker, and if we are to utilize it for some purpose or some research purpose, how do we go about this? That is what we are going to see in the coming slide. Okay, so what are the components of the wearable device? So when I understand, okay, I want to have a eye tracker which has EOG embedded with it, which has a camera as well within the glass itself. You can think about on your temples, or in your nose slits. Okay, you have camera embedded within the eyeglasses. Then what it can do, it can actually capture the EOG data as well. It can capture EEG. It can capture the eye movements as well using this camera. So all those things can be done using these sensors. So what can be done? So first of all, you can identify what kind of sensors you want to place in, like whether you are going to use wet electrodes, you are going to use dry electrodes. Mostly we prefer dry electrodes, because it is you don't want something to be sticking onto your system for 24/7, right? That is not very comfortable. That is not um, comfortable for you using it in day-to-day life, right? So we generally go in for electrodes, dry electrodes. So how to fabricate them, all those things are very very much in the research right now, how to fabricate, what kind of electrodes to use, what kind of systems to use. All those things are in the market. The other thing is signal conditioning circuit. So what kind of signal conditioning circuit should I need? So depending on what sensors you are using, the integrated circuits that you are going to use after the system or after the sensor are going to vary. So what kind of modules you need? So you need amplifiers, filter, you need to work on power management and ADC, wireless transmitters, receivers, all those things. In the other stage, you have something called as edge devices, where you can think about edge devices as local servers or simply simple edge devices like microcontrollers that are handy, or you can have cloud-based data collection and storage system that are also being trending in the market now. So you can have different kinds of edge devices, and that needs to also be integrated within the system. The other module that is very important now is what we talk about is signal or image processing systems or image analysis algorithms that are being fixed into the edge devices, local servers, or cloud-based servers. Now, why is this important? Because imagine you're wearing something 24/7, right? So how much of data you are going to get, it depends on how long you're going to record that particular signal. So I am wearing an eye device and an eyewear, like for example, I'm wearing an eyewear. I want to record the data continuously 24/7. So and per second, if you think of, if you take a video image, okay, or video recording per second, you have 30 frames, okay. So you can imagine 30 images for 1 second. Like this, you will be having for 1 minute. So 30 into 60. So you can think about that for 1 hour, that for 24 hours. So how many images you have? So all the processing of all these things is very important. So what you want to store? You want to store it as an image. You want to store it as some data. You want to store it as some what to say, some feature. So that is very important in this particular condition. Okay, so this is where we will be concentrating more. But anyway, I will be talking about a few advancements in sensor technology as well. We will in the next half an hour we will try to understand the sensor technology and the signal and image processing analysis, how people are doing it in a detailed way. Okay, so what are the limitations that are there in the existing wearables? So whenever we talk about all these components, we also need to talk about limitations, right? So what kind of limitations are there? First and foremost is battery, right? So people who are having smartwatches, they will be able to understand it better. So how many times you would need to charge your device? But people who are having analog watches, they don't have to worry about battery that much. Once a year, you change the battery, that is good enough, right? So sometimes you can take 2 years to change the battery. But in this particular scenarios, battery life is very important. And also, if your device is actually requiring to charge every 1 hour, people will not be interested in using it, right? So every 1 hour I need to charge a device. And also one more thing is the how much of battery is, I mean, what is the size of the battery, right? So that is also important, because I cannot use a heavy bulkier battery, because I need to wear it, I need to carry it. So that is not possible. The other important limitation is about standards. So there are no standards as of now that are established for these data collection, right? So I am recording videos of the eye. You can imagine eyes can be used as a biometric, right? Like other validation and all, you can use. They use eyes, like they use iris. As a metric for validating or identifying the person as in a biometric, right? So if I am collecting these data continuously, is there a risk of privacy? All those things are there. So what are the standards that I have to follow for collecting this data? Is there anything that will actually hinder the usability? So all those things are still in question. There are no particular established standards as of now, but people are actually working on it. BIS, that is actually various Indian standards formulated by Indian government, is actually working towards making wearable standards. Right now, people are focusing more towards what kind of standards have to be formulated, because for other medical, so these are devices that are not in the diagnostic perspective, but still they are in the wellness zone, right? So people are using it for wellness, people are using it to identify whether they are what is the what is it what is their health, how their health is, all those things. It is just a wellness device, it's not a diagnostic device, that we need to be very sure. So what are the standards that are required for these wellness devices? And the other thing is about affordability, that is also very important. Reliability, I told you. Okay, I'm collecting some device. You are giving me some data. You are saying that data is the device is. I mean, you are having some kind of risk to eye disorder or eye infection. How reliable is that information? What kind of information is that? So that is also very important. Also, we have technological limitations to this. Okay, only certain functionalities are actually possible with that particular hardware, or as I said, wearable. The other functionalities needs to be incorporated. So that kind of technological limitations will have. And also one more thing is, this is very important, biodegradability. So we have so much of e-waste that are being generated, right? Medical waste, e-waste that are being generated. So this also plays an important role. And also one more thing is comfort, because wearables are something like an accessory. People get accustomed to it, but whether is it comfortable or not, that is again a question. The other thing is security and privacy, as we had mentioned. So, what kind of privacy is are being considered when we are actually looking at the at these kind of wearables. So now, looking at all these things, we have one thing that is standing out. One that is biodegradability, which are actually in the market right now. So we are thinking about eyewears, right? So what kind of eyewears are there? So whenever we think of eyewear, there we think about some plastic or some metal glasses which are worn, right? Why can't it be something different? Why can't it be like a headband or something that integrates smart textile? So this is the next gen electrodes which are actually there. What are these next generation electrodes? They are something called as textile based electrodes. You can see this is a headband that is actually being in research. So this headband is something similar to eyewear as well. So within this headband you have electrodes integrated. So these electrodes are capable of capturing the signals, that is EEG signals or EOG signals, all those signals, and it is able to capture and process them through, you can see the electronics here. So it is able to capture and process them. So these kind of textiles based electrodes are being in market, or I will not say in market directly, but they are still actually being commercialized for utility in capturing the biosignals. So, what kind of smart textiles are being used? What are these smart textiles primarily? So, they are simply textile fabric. What you and what we are wearing, right? So, these textile fabric. But simply, if you use a textile fabric like our everyday garments, that is not going to record or sense any electrical potential. So, what are these that are going to sense electrical potential? So, we need to. So, these fabrics that are being worn by us, they are all called as insulators. So what they do is, they do not um, transmit the electrical potential from the skin to the other plant. So we need to make it conductive, right? So we need to incorporate the conductivity property to that particular system, right? So how to make it conductive? So we have something called as passive smart textiles. What they do is, if I am able to make a fabric or make a textile that have conductivity properties, then these textiles can sense something that is there in the environment. That is, you can think about different environments. What I am identifying right now is EOG. You can think about an electrode placed on your head. So that smart textile or smart electrode can actually sense what are the changes that are happening in the biopotential, and they are called as sensors. There are other category of smart textiles, such as active smart textiles. What these active smart textiles do is, they can sense the changes that are happening in the nearby area. Also, they can react to it. Okay, a simple example I can give you so that you'll be able to understand it better. You can think about fever patches. Have you heard about fever patches? In the sense that if I can place a patch on my forehead, depending on the temperature. Okay, these sensors can sense what kind of temperature the person is actually having, and and in particular stimuli. That is, it will change color. Okay, basically. So depending on how much temperature you are having, it can change color. If you're having a normal temperature, it will not show that much of changes. But if you are having a fever, it will change color, and depending on the intensity of the color, you can actually calibrate the temperature. Okay, so those are kind of active smart textiles. We also have something called as ultra smart textile. What it does is it can sense, react, and adapt. You can think of fever patch. It is actually sensing, it is reacting, and it can adapting. It is providing a cooling effect, okay, to that particular temperature. It is providing a cooling effect. Then what it is doing is it is adapting itself. That is what is called as an ultra smart textile. Okay, so these are the different types of smart textiles. Now I have electrodes. I have you can imagine I have a sensor. The sensor, I can make multiple types of sensors, like for example, wet electrodes, dry electrodes. In the dry electrodes, you can have textile based electrodes, and you are having a sensor that is being formulated. You are integrating it with the eyewear, okay, and you are using that to collect the data. Now, the next important thing is I have data right now with me with the help of these sensors. What am I going to do with the collected data? That is very important, right? So that is where this integration of artificial intelligence comes into picture. This was why I made my talk to be as wearable intelligent devices, wherein intelligence come into picture. Okay, so what are these artificially intelligent wearable technology? Now, if I am integrating some AI technique or AI methodology into the wearable technology, then I make the system to be a smart system or an intelligent system. And why do we need this intelligent system? Because as I told you in the previous few slides, what happens is I am collecting too much of data. Okay, if you are going to compress the data or identify some inferences out of the data and store it, the storage space that is required to store it is quite less when compared to storing the data as such. You imagine storing the entire video of your eye image completely, eye image completely in the server. Okay, so how many days you need to store? So you will have always have a limitation, right? So instead, if you think of extracting some useful information from that eye image, okay, and storing only that data, which occupies less space, and I am discarding the other things. Okay, so this will actually enhance the technology. This is one thing. This is in one perspective, like storage perspective. Like that, you have different perspectives. If I want to I infer something from the system, like for example, whether the person is having an infection, what kind of infection he is having, what kind of what is the emotion level of that particular person. So all those things can be identified using these smart technologies or artificial intelligence technology. Okay, so the market space, if you can see for the AI integrated wearable market. So wearable market itself, we have seen that there is a huge growth, right? So if I see the AI integrated wearable market space, obviously there is a huge growth from 2020 to 2027. Nice improvement is actually seen predicted for the AI integrated wearable market. So if I can say infer some health conditions, that is going to boom the market as such, right? So people are working towards integrating AI in different arenas, and this is also one of the arenas. So why do we need this? So I told you there are different examples. The one of the interesting example is also in increasing the user experience. So you imagine your algorithm adapts the wearable to improve the experience of the user. So people are going to like it more, right? So that is one more thing for AI integration. Accuracy of the prediction. I want a real time monitoring. Like for example, if something that is, you imagine you are using the eyewear to predict stroke. Okay, so whether a person is having a stroke or not. So stroke are something that needs to be treated within the golden hour, right? So when I use these kind of glasses for predicting these things. So when I then I need real time monitoring. If I need real time monitoring, I need to integrate some intelligent technology. And I also have predictive maintenance of the the system that is being put in use. And I also have improved interaction, life expectancy, life quality. All those things are being enhanced by using the AI. Okay, so this is what I wanted to focus more on. So we will talk now about HCI. I had shown a small introduction in the previous slide, but what we want to do right now is I want to uh, inform on how the AI integration is possible with the help of these kind of systems. Okay, so first of all, let us consider that there is a person who is in a who's a specially abled person who is actually recovering from stroke. Okay, so some kind of limb deficiency is there, or they are plegic in nature. That is, they can be quadriplegic, diplegic, or hemiplegic, paraplegic. So there are different kind of plegic conditions, right? So they will not be able to utilize they will not have their motor functions. So it will be partially disabled or completely disabled as well. So these kind of people, when they want to control some system, so how to do it? So this is basically human computer interface, human machine interface, brain computer interface, all those things. Now when I want to use these systems, so you can think of him wearing a eyeglass which is a wearable device which has something called as EOG sensors that are integrated. Also, it has a camera embedded within it. So wherever the eye movements are, you can see different kinds of eye movements are there. Based on these different kinds of eye movements, I am actually controlling the computer, right? So right now, what I told you is two things. One is two sensors are there. One sensor is actually EOG sensor. The other sensor is a smart, what is it, camera, right? So camera is going to record videos. Now, what is the information or a signal that I will get as an input? I will get either a signal, that is EOG signal, or I will get images like this, right? So we will talk more about images now because this is very interesting. This can you can visualize it better. So I thought of looking at image perspective, right? So you can see here, this is the so very first step of AI integration is I need to have a good amount of data. Right? So what is the data that is coming out of your system? So right now, when we are focusing on eye images, you can see there are different kinds of noises or artifacts that will come across the system. So in this particular example, what they are focusing on is cornea identification. You can see cornea is something. This is the white portion is there, right? So this is called as cornea. Okay, so here there are different images that are being captured. You can see these images. So the first image is actually a defocused image, like in a sense it's a low quality image, right? So I don't have cornea visible at all. You are not able to see any cornea in this system. The second image you can see, it's an overexposed image, right? So overexposed image in the sense I am not able to visualize a cornea, but I'm able to see some part of the eye. So the illumination is too much. Too much of illumination is there in the image. The third image is underexposed. So you can see some part of cornea here, but here it is not visible. It is completely dark here. Now, the fourth image, it is actually capturing the cornea correctly, but only a part of cornea is visible. You can see this is actually cornea. This is a good image. You can see this is cornea. If you can understand this. Now, in this image, only part of the cornea is actually visible, right? And here also you can see only incomplete. I mean, the positioning of cornea is also not correct here. So, like this, you have different quality of images that can be captured, and based on this, you first I need to identify the quality of the images that are coming out of your wearable device. Okay, so what kind of quality is being coming out of the system? If you have a good quality image, very good. This is a good quality image. Then it is very good. You can actually go forward with that itself. If you don't have a good quality image, what you need to do is a pre-processing. Okay, so what kind of pre-processing techniques can you carry out? There are different techniques. One is we mainly do something called as illumination correction. We also carry out something that is positioning. So sometimes eyes will not be in the position of the where the sensor is. Okay, so you need to reposition the eye. Either you can, if you can do it using some algorithm, it's good enough, or else you need to record the image again separately. Okay, so what are the different pre-processing steps that we need to do? So we can try out a grayscale conversion because it simplifies the computation. That is, instead of having RGB, RGB is actually a three-channeled image, right? So I have R channel, red channel, green channel, and blue channel. So if I have all three channels, then it makes my computation difficult, complex. It is not difficult, but it is complex actually, right? So if you can simplify it, it's good. So then if you have some noise in the system, you can filter it using some median filtering. If you have some illumination correction or contrast is not correct, good enough, then I can actually um, use some contrast adjustment or histogram equalization. The other thing is I can also use glare removal. So glare is one more thing which is actually specifically in your pupil. So this is your pupil region, the center region. So in your pupil, you have too much of glare, a reflection in the image. Okay, so that creates a bright spot. So these can be managed using this glare removal technique. And also, if you're using EOG, so we have something called as blink detection. So even in images also, sometimes your eyes, sometimes when you're blinking, it is still recording, right? So these blinks can be identified and they can be removed. So these are all the pre-processing that you need to carry out. Then what is the next stage? So next stage is I want to use some kind of AI integration. So if I want to do AI integration, there are two techniques basically that you can do. One is called as a machine learning technique, and the second one is deep learning technique. In the machine learning, we generally, so the input will be a pre-processed image, and we extract the features from the image, and we use some classification model, and that will give us some output. Okay, so this is a broad overview. We will go into detail in the coming slide. The next thing is about deep learning. So what how deep learning processes are carried out is whatever is a pre-processed image that is given to a model which can do two things together. One is it can extract the features as well as it can classify by itself, and it can give us the output. So let us go one by one. We will try to understand the machine learning first. Okay, so what kind of features that can be extracted from the machine learning techniques? So I can extract two types of features. One is called as pupil based features or the eye movement based features. I have to reiterate again. Please remember that we are using wearable glasses, and within the wearable glasses, I can either have EOG electrodes that are being embedded within it, or and also I can have camera sensors that can capture the eye images regularly, that is as a video continuously, and from these I can track the eye movements, right? So what are the eye movements that I can track? So there are different kinds of eye movements. So fixation is one, saccade is the other. Saccade is actually moving the eye from one point to the other point. Smooth pursuit, so I'm tracking this point, that is called as smooth pursuit. I'm blinking, so I can identify how many blinks are being have been done by the user. And also I can do something called as visual search. So there are different features. So you can see, you can count the number of fixations, you can see the amplitude of the sucker, duration, velocity, latency, um, rate of saccade, so gain, so all those things you can identify. Then acceleration you can identify. These are all different features that can be extracted. Okay, I'm not going into detail about these features. That is why I'm just listed out. There are other things as well. That is pupillary based measures. Pupil measures are something that identifies what is the pupil diameter, what is the latency of the pupillary reflex, the index of the pupillary activity, that whether what kind of activity is there, and what kind of cognitive activity is there. So all these things can be extracted from the pupil data. Okay, so when I have a pupil data, or when I have these features extracted, whatever you want, you can extract. Actually, there are infinite number of features. Whenever I talk in class, I will say you can extract infinite number of features. But what is actually important is identify what features are actually discriminative or not. We call something as discriminative features and non-discriminative features, right? So identifying these discriminative features are a task actually. Okay, when we have identified discriminative features, what you do, you give it to machine learning model. So you can either formulate a supervised learning model or an unsupervised learning model based on the data that is already collected. So all these things are already collected. So I have already collected data. I extracted some features out of it. I am using a model or training a model. So the model can be a supervised model or an unsupervised model. So depending on the application that you have, you can either use a classification model or a regression model. If you want to classify whether the whatever is has happened is normal or abnormal, okay, then you can use a classification model. If you want to predict something that is going to happen in the future, then you can use something as a regression model, right? So this is a simple example. You can use regression for other purposes as well. So I'm telling you a simple example. So in classification model, I have different kinds of classification model, starting from k nearest neighbors to neighbor-based decision tree, support vector machine. Like that, I have different models. Similarly, in regression model also, I have different models that are starting from linear regression, logistic regression, decision trees, support vector also can be used as a regression. And in unsupervised learning, you have something as a clustering based models that can be used as a unsupervised model. Okay. Traditional model that works in this category, like what I have mentioned previously, right? So traditional models always work in, like, for example, data collection. Um, you extract features, pre-process data, extract features, then train the model, evaluate the model, and then that evaluation will give you a classification. Okay, so but there are something called as auto ML workflows. So auto ML are advanced version of machine learning algorithms. What it does is it will automate the end-to-end machine learning model creation. That is a pipeline. It will actually do it by itself. Okay, including it does the data preparation, it can extract features by itself, it can select the model, it can also hyper parameter tuning can also be carried out by this auto ML. So there are different models that are being released by Google, Meta, Amazon. So all those high top players in the AI market, they all have given out the AutoML workflow, AutoML model. They are all available for us to use actually. Okay, so this is about the machine learning model. Okay, so from the machine learning model, the one advancement that have been happened as an extension of a machine learning model is a neural network. Okay, so what is a neural network? Neural network imitates what happens in the brain. So the inspiration is taken from the brain is composed of different neurons, and this is from this only the terminology coined like neural networks. Okay, it was way back in 1960s, 1970s, where sorry, 1960s. I will even before 1960s, people try to understand the neural networks. That is when the so you can imagine, we all try to understand AI, or the influence of AI is more in this era right now. But the starting point is to 1960s. Okay, so from the point where neurons were identified, and how the functioning of I will not say neurons are in, but the functionalities of the neurons are actually predicted and put into place. Okay, so the one interesting part of these neurons are the formulation of a network called as perceptron. Okay, so this perceptron is something that is taken inspiration from the neuron activations. So you can see this is an axon, this is a neuron. Okay, so the neuron has a nucleotide, an axon, and there are branches of axon. So these are called as dendrites. The dendrites take in input information. Okay, so the input comes, you can see x1, x2, x3 are all inputs. So based on these inputs, weights are being formulated. There are different weights. So each particular dendrite is given different weights, and it is all summed. And based on the summed value, the axon has something called as an activation, whether it will decide whether it needs to transmit the input to the next neuron or not. Okay, so that is what is the formulation of the perceptron. So and if I this is a single layer perceptron, right? So like this, I can have multi-layer perceptron as well. So this multi-layer perceptron, multi-layer perceptron was what actually got converted into neural networks and other things, right? So this has a single hidden layer. You can see an input layer, a hidden layer, and an output layer. And now this whatever is going to happen is called as a feed forward neural network. In the sense, it is actually feeding the input data forward to the hidden layer and to the output layer. Now, based on the output that you are getting, okay, it need not be actually correct. So what people have formulated is they back propagate depending on the output, whatever they are getting, they back propagate the weights and the model is being trained again and again. So the extension of this back, feed forward and neural network and the back propagation of weight is what came into called to be as deep neural networks. So in the deep neural networks, we have multiple hidden layers. So you can see this came in something called something at about 1990s, and based on this, we have formulated many different kinds of works that are there in picture. Okay, now based on these perceptrons, I'm going back to perceptrons. Perceptrons do very well, but whenever we are randomly initializing the weight, okay, what happens is they tend to not produce, they tend to fail to train to that particular or to adapt to that particular data. So what people have done is that is in this particular case, back propagation does not work very well, and that is why people they stopped at that point. They were not able to progress further with the help of this same standard learning strategy. That is feed forward neural network and back propagation of weight. Okay. When this failed, whenever there is a random initialization of the weights. So what people did is they use something called as unsupervised 3D layer training. So this algorithm, what it does is it utilizes and it trains layer by layer. Okay, so this is the first. You imagine this is the complete network. So this is the input layer. This is the first hidden layer. The first hidden layer is actually getting trained, and it tries to predict the input after training the first hidden layer. And this model will get trained until and unless the input and the output at the different stages, that is it is matching. Okay, now after the first layer is being trained, this the weight of this layer will be fixed, then the next layer will be trained. So this layer is again trying to predict what are the first layer, the weights or the inputs of the first layer. Okay, like this, it will train layer by layer, and finally, this is the final model wherein all the layer-based training has been completed, and this is actually predicting the output. Now, the entire network is again fine-tuned, and you can add a classifier or something like that and perform the back propagation to refine weight. So this is an advancement to the multi-layer perceptron. Okay, so wherein it is not just not random initialization of weights. So in multi-layer perceptron, what we do, we initialize these weights randomly. But here, the random initialization of weights is not happening. Rather, what we do is we try to tune the fine tune the model layer by layer. So like this, people have formulated different models. So I have shown you different kinds of models here. So you can see starting from perceptron to feed forward neural network to radial basis network, deep networks. We have this and all we will see now. So we have RNN, LSTM like that. We have support vector mission. We have spiking neural network, GAN models right now. So there are different kinds of network that are being formulated. And if you can see, all comes from the base of perceptron only. Okay, so the base of everything is perceptron. What they are doing is they are slightly changing how it is actually being carried out. That's all. So the deep learning architectures broadly, I am telling you broadly, this is not the only two classification. If time permits, I will show you the classification as well. Okay, so broadly it can be classified as supervised learning and unsupervised learning. So in supervised learning, we have different kinds of models like CNN, we have RNN, recurrent neural network, long LSTM, we have GANs, autoencoders, some self-organizing map. So like this, we have different networks. So what are these models actually? What these deep learning models do? It is actually multi-layered models. Okay, they are, you can see, and it takes again inspiration from the brain only. What it does is it does high level of abstractions. So every layer, it is capturing different information. You can see this is the image. Okay, so from an image, what it does is for every layer, so this is the first layer that is capturing, this is the second layer, this is third layer. So every layer is capturing different kinds of information. So you can see first layer is actually capturing the edges. present in the image. The second layer is capturing the primitive shapes. So like you can see eyes are captured, nose is captured, like that primitive shapes are being captured. In the last layer, higher level layers, you can see the whole face is being captured, right? So the high level abstractions are being captured. So every layer is actually giving us different informations. That is what is the base for these deep learning models. So it progresses by learning, okay, and it progresses by hierarchical feature learning, we can say. Now, this is the base of convolution neural network. You can see convolution neural network has two kinds of two parts, I will say. One is a convolution part and the other one is a fully connected layer. So convolution part, what it does is it will take an image, whatever is the input, and it will use different filters. There are different filters. These are different stages, right? So there are different filters in between these stages. They use different filters to extract different features. So if I can show you a video, I'll show you a video and we can see. I will try to understand. Okay, okay, it's not playing. Okay, just a moment. Okay, you can see this video. So this is a abstract example of how convolution neural network works. What they are doing here is, I will again play it. You can see here, they are actually taking an image. Okay, the image is actually cut out into strips, and they are alternating the strips. You can see, right? Now, what is being done? You got two images now, two similar images. You can see. And again, they are cutting the same image into multiple strips again in a different direction. Direction is different now. But, and they are trying to rearrange it alternatively. What is being got is, you can see four images, four dog images are being got. This is the same thing that your convolution neural network does. Okay. Initially, it takes the whole image, it does convolution on this, okay, and it extracts features. What is convolution operation? It is actually trying to extract different features using this convolution operation, nothing else. Okay, it is extracting multiple features using these filters, and it is actually reducing the size of the image. So we have two things. I'm not going into detail. So filter convolution operation, convolution networks does two things. One is convolution and pooling. This pooling is only what was actually this division, whatever is happening, right? So after extracting the the low level features, that is from the entire image, they do a pooling operation. They reduce the size of the image. Okay, from the reduced size, you can see these four images. You can see, right? Now in these four images, you cannot capture every single detail. So in some images, eyes are very visible. So you can see here eyes are visible. Here eyes are not visible. Here you can see the nose shape. Here and all you cannot see the nose shape, right? So all those things are different, right? So but in these images, in every image, the shape of the dog remains the same. You can see that it is a dog, right? So these are all called as higher level features. Low level features are edges, something like that. And higher level features, as you go deep into the model is going to capture the higher level features. In 9 cross 9, it is going to capture the higher level features. So like this, every feature is being captured, and the model is being trying to extract these kind of features, and it is trying to learn from these features. And in the end, it is having a fully connected network. This is nothing but like a classification model, you can think of. So this classification model, what it's going to do is, it is going to separate it out as whether, like for example, if it is a cat or a dog, like, or if it is normal or an abnormal image, something like that, it is going to give you an outcome. So this is the base of convolution neural network. So there are different common types of convolution neural network that are being in a market, in the research or in the field right now. So it started from DNet, and now we have here it is. I have just shown you till 2019, but right now you have different kinds of convolution networks that are like UNet. We have even some of the transformers have a base of convolution neural network. So like that, we have different models, and this is actually the number of layers that are there in the convolution neural network. You can see from we have different networks that are having different layers of different hidden layers, different kinds of convolution and pooling layers are available. So all those things are there. So and AlexNet is an initial formed network, you can see, and this is a small network which is having only 7 layers and is including us and also a small softmax layer. Then comes BGGNet like this. Then we also have ResNet. These are all residual networks. So residual networks have something called as skip connections, which are known to tackle the effect of vanishing gradient. I am not going into details of all those things, but still you can actually go into it and try to understand if you are interested. And we also have something like UNet plus plus, which has skip connections, you can see. And this is a major, it's an encoder decoder architecture. So you can see this is an encoder. This is where the feature vector is being formulated, and from the feature vector, it is actually decoding it, and you are trying to reconstruct the image. Okay, so this is an encoder decoder architecture. So just 1 minute, I will just complete it. So you can see these are the different types of networks, deep learning models that are being available, that are being researched upon. So it's classified. I told you the broad classification is supervised and unsupervised learning, but we also have something like self-supervised learning. We have semi-supervised learning. Self-supervised learning in the sense where the model does not have labels, so it tries to create the pseudo labels, which where we call it as contrastive learning. And we have semi-supervised learning, that is and also we have something called as reinforcement learning, probabilistic models, graph learning, graph based models. And we also have multimodal systems, multimodal deep learning models. So all those things are available. So in supervised learning, we have CNN, we have LSTM, recurrent neural networks, vision transformers, or the other transformer models. And in unsupervised learning, we have GAN based models, generative adversarial networks, where we try to synthesize some images, and we can have auto encoders, we can have self-organizing map. And in self-supervised learning, we have contrasting learning approaches, we have image modeling, and we have also prediction models, some kind of prediction models that are available. We have different semi-supervised learning, like pseudo labeling in the sense like I'm trying to create labels or pseudo labels. A model is trying to identify the pseudo labels, like kind of it is kind of self-supervised, but it is having some label information that is available to the model. But again, most of the data is actually unlabeled. When you have that kind of images, you use semi-supervised learning. We have reinforcement learning, like for example, you give a reward to the system to when it is actually performing correctly. So that kind of models are also available. We have imitation learning in robotic setups, you can see imitation learning. So whatever a human is doing, it will try to imitate the human, and the robots will actually perform similar to humans. So that is called as imitation learning. Like this is mainly used in human robot interactions. And also, we have models, Bayesian networks, we have HMM, deep learning based HMM models, and we have graph neural networks, we have spatiotemporal graph neural networks, and also we have fusion models. So these fusion models are something if I have multiple data like eye images, EOG data, EEG data, and other things, you can use fusion models here. You can also use cross model transformers. So there are transformers that are available, so you can use cross model transformers also. So this is an overview of all the deep learning models that are available. One small example I will give you. This is one research article specifically on eye based tracking. Okay, so you can see this is the eye data that are being captured. If they use a normal ellipse fit, like normal simple feature extraction and identification, the model is actually not trying to exactly fit the into the pupil region or the iris region. So what they do is they try to record images, like record data, that is NIR based eye images, visible RGB based images, and they try to create a protocol, okay, for iris or pupil tracking. And they are trying to predict the gaze. So how are they doing? They are using these you can see the eye I mean glasses, and you can see the images, sorry, the camera here. So the camera is actually tracking the eye, okay, eye movements, and it is actually, you need to do a labeling, you need to do create a database. And after creating the database, here they are using YOLO based model. YOLO based is also a supervised model where it is a CNN based architecture. Okay, so this is actually trying to predict the pupil. You can see this is the final output. The pupil is being predicted. So in most of the images, it is able to predict pupil. That is what is the claim of this article. So Like this, we can use different kinds of setups, different kinds of training models and deep learning models integrated within the eyeglass eyewear, so that we will be able to better predict the uh, uh, better predict the any condition like disease condition or any other infection conditions things. So finally, this is my last slide. So I will just complete it with the overview of different wearables that are there in the market to detect the ocular conditions in children, particularly. Okay, so there are different disease conditions. You can see we have given four kinds of disease conditions: refractive errors like the near vision, far vision, and all other things. And we also have this is another category of dry eye disease, strabismus, and glaucoma. All the other disease conditions are uh, these are the common disease conditions that are present in the children, specific to the ocular health. And we have different technology like portable technology, and they are also commercially available. Okay, so these are the commercially available systems that are there in the that have been listed. So there are multiple systems that are available in terms of wearable, if we can think of, but these systems are not completely utilized here, but it is still in the research phase. So, as researchers, we are actually accustomed to do a research that can be commercialized, that can be taken to the next level, transferred in technology, and have an industry working out with you, and you utilize them for making it for the betterment of the society. So that is where our role lies in. So as a researcher, we are bound to do it. We are capable of doing it, so it will be very nice if we can be a part of this societal improvement. And that's it. So this is finally what we do in our lab. So we have a lab in our institute, Thrive Lab. So we focus mostly on different arenas, like different verticals like image processing. We work on pattern recognition, we work on model formulations, even in electrode technology and image guided intervention. So these are all some of the experts of our work that I have shown here. That is from my side. So thank you very much. If you have any questions, you can ask. You can feel free to interact. And this is my mail ID. If you want any information, or if you want any um, help from my end, so you can always write to me. I can support you to the best possible of my way. So yeah, thank you very much. If you have any questions, you can please interact.
So the floor is now open for a short question and answer sessions. If you have any questions for the speaker, please feel free to raise your hand and put forth your queries.
Ma'am, very good morning, ma'am.
Yes.
Ma'am, do you give some idea of the difference between the CNN and DNN, ma'am?
Yes. Sorry, you want me to give the difference between CNN and DNN?
Yes, ma'am. Yes, ma'am.
Okay. See, deep neural networks are something. Okay, I'll just go back to my slides.
Okay.
So, deep neural networks are a broad category of neural network in the sense, if you start with a neural network, so if the number of hidden layers primarily play an important role in the way the system or the network is learning actually. Okay, so if you have more number of hidden layers, it is actually understood that the model is actually learning more and more. Okay, so
Okay.
the data is actually transmitted through multiple layers. So more and more information is being collected from the data, from the input image or the input signal, and the a model is able to learn better for better feature representation and classification. So deep neural networks are a category of models that include only these kind of neurons which are interconnected to each other, like this. If you can see my screen, the
Okay.
first image is there, right? So these are interconnected neurons that are there with different hidden layers, and these layers are actually used to collect or extract the features from the input. That's all. It is not going to do anything more. Okay. Now the difference between okay, I will triplet layer is there, right? This
Okay.
layer is called as this layer again is a deep layer. It's a neural network again. Okay.
Yeah.
But in addition to this layer, it also has some convolution layers. Like you can see here, different convolution layers are there, right? So these convolution layers have something called as filters that are embedded
Okay.
within.
Hmm.
These are all predefined filters. Like you can see here, 16 filters, 32
Okay.
filters. Like this is given, right? So
Yes.
these are filters that are embedded within the model. Like you can change this in according. So what these filters will do is it will extract the, like for example, horizontal edge is there. So there is a filter that can extract the horizontal edge. There is a filter that can extract vertical edge. Like this, you can extract multiple things from the image. Or this convolutional neural network is mainly used for image actually. Okay. Deep neural networks, you can use any data. Like for example, any data point you can use. You can use it for a signal. You can use it even extract features from the image, and then you can use the deep neural network. But CNN, we generally use it only for images. Okay.
Okay.
So from this, we extract these information, the feature information, and then from in the last layer of this convolution, what happens is we get only features here. Like for example,
Okay.
it will be like data points. So these data points are given as an input to the feed-forward network. This is again a neural network, a deep network, depending on number of neurons, the number of hidden layers here. So it will
Okay.
be a deep neural network.
Okay.
So deep neural network by itself is just neurons that are interconnected with each other. CNN is something that has in addition to DNN, we have convolution layers. That is
Okay.
what's a CNN.
Okay. Thank you, ma'am. Thank you.
So if there are any queries, you can email ma'am. So thank you, ma'am. Your session has not only expanded our technical knowledge, but has also inspired us to think critically, explore new directions, and appreciate the profound impact of biomedical engineering on the society. Thank you once again, ma'am, for your valuable time, your dedication to knowledge sharing, and your contribution to the success of today's program. We look forward to many more opportunities to learn from you in the future. Thank you so much, ma'am.
Thank you very much. Thank you for the opportunity. I would like to thank